So we went over the first one already, right? You know that relationship. Therefore, have you seen this before? Yeah, I think I have. An excellent question. Anybody? What's the domain of the natural log function? It's only positives, right? We will get to the point where we're doing definite integrals where there could be negative numbers here. And because the domain is positive real numbers, we have to put absolute value on there to deal with those negatives. Okay? So that is because domain is that's how we deal with some of the negatives. Don't forget that, because there's a very possible, it's very possible when we get to differential equations that will pop up and you'll have to actually throw a negative. Okay. Again, I'll show you how to deal with it, but for now, that's what you're going to do. Okay. Here's a yeah. So it's 5 over x minus 3x to the negative 10. I just need to slow down on this thing. I write too fast and I don't pick my pen up and it just gets a mess. So, old knowledge from yesterday, a little bit today. What do we got? Yeah? It's here, right? X to the negative 9 over negative 9, which would be 1 there, right? Okay, so remember, add 1 and then divide by that number. How are we doing? This can also be written as such. Same problem. Right? The only time we use natural log is if this is x alone. If it has an exponent on it, we need to change it to the negative exponent power rule, just like derivatives, right? So be careful there. All right? Again, we forgot something. Good? How about yeah. That's just a derivative right now, so we don't put a constant. But then if we do anti-differentiate or integrate, right? This is easy stuff. Sometimes you're going to have to deal with the chain rule. Okay, so copy it. Right. Times the derivative of chain rule problem. The reason I put that there is that's what I want to do. How do I deal with a chain rule, a simple chain rule in an antiderivative? That's exactly what it is. It's just like the power you divide. So again, 7e 7x plus 2. We have to divide by 7 to manage that chain rule. Okay. So these would cancel out and you'd end up with your original now, correct? So if you see something with a simple chain rule and an antiderivative, you divide by that. With a chain rule, you multiply. For derivatives, antiderivatives, you divide. Okay. So keep that in mind there. So something such as, you may not have this number out here. E to the x, and then what do I do with the 5x? Can't do that. Okay, there you go. So the 5 in the denominator will not cancel out this time. I'll show you sine and cosine here in a minute. It's the same thing for all of them. Are we good with that? Hopefully. Again, recycling stuff, you know. Okay, let's talk about sine. What's the derivative of sine? Cosine. Thank you for having that memorized. Get your noses in those memory cards. That means that the antiderivative of cosine is sine x plus c. You kind of have to fiddle with these a little bit sometimes. Maybe. What? I can't hear you. Oh, you said negative. Right, so derivative of cosine is negative sine. You're going to be presented with an antiderivative of sine x. There's no negative here, right? So what is the answer going to be for that antiderivative? Negative cosine. Okay. So be careful with those negatives and that relationship and how you deal with them. Okay. Do you want me to write down tangent, cotangent, secant, cosecant? Yeah. Okay. Do you want just the integral or both versions? That's fine. I'm going to start calling on you for answers just to check. Question? Derivative tangent? Yeah. So the integral of secant squared is that. Oh, I should have. So you guys need to keep your eyes eyes on me. Well, I told you, why am I not an engineer? Because I do something stupid and the bridge would fall in the river. I want to kill myself. No, I really wouldn't. I would be very upset. And so would a lot of other people. We will work on the antiderivative of tangent later this quarter, but it's not just a simple derivation. It's called substitution. So there's, for now, I'm not going to show you tangent. Let's go with cotangent. Remember that? Yeah. Again, patterns, right? Starts with a co, has a negative. Okay. So we could say that the antiderivative of cosecant squared is negative cotangent. Again, cotangents are rather messy in antiderivatives. Good so far? And then what are the others? Secant. So you can imagine the antiderivative there. And then we could also do cosecant. And then the antiderivative. You want me to write those down? Alright, one last little thing. A lot of time to work today. I'll let you check. We're going to talk about the chain rule within these. So, it shouldn't be a big deal, but so, if I asked you to calculate the integral of sine of 5x plus 1, how are we going to deal with that? Same as e to the x. So what is my answer? Again, if it's a simple chain rule problem, take that derivative, divide by it. And I could check that answer by calculating the derivative, right? I didn't look it up. Good enough? Seeing a lot of head nods, so if you don't understand in the next half hour, please vote me in so I can explain it to you. Not spiraling still. This will be due tomorrow.
I guess he just likes staying on.
Like you on.
Yeah. It's meant to be a compliment when he's
Make sure you work those first and then check your answers, as always. Okay. Thanks for your time. Hopefully you get that done by the end of the